So we have all these rules. Tomorrow we're going to learn a couple more rules. So you have to keep these straight, and it's kind of like I compare it to the unit circle. When you first started pre-cal, we gave you this unit circle. You were like, "There's no way I'm ever going to learn that unit circle," and now it's easy. Ish for most of you. Okay. Same thing here. At first, it seems like, what in the world? I'm never going to remember all that. It's going to be very, very easy. So like the problems that we've been doing, y equals 2x squared plus 3x minus 7, where you had to plug in x plus h wherever there was an x, multiply that out, distribute, combine like terms, cancel, factor, cancel, all of that. You're going to be able to do that in one step. So instead of it being a half a page long of work or a whole page, it's going to be one line. But you have to remember all of these different possibilities. So the first thing, the derivative of a constant. So d over dx, just a notation right there. Same as if we said if it was f of x equals f prime of x. Y equals y prime of x. The derivative. Differentiate. All of those words are interchangeable. So the derivative of some number equals 0. Some number, 3 is a number. Pi, is pi a number? Yes, it's a number. It's a symbol, but it represents a number. So the derivative of any number is equal to 0. So if you have a number, 0. You're done. The power rule. This is what's going to really change your life right here. Okay, the power rule is wonderful. You take the derivative of x raised to some exponent. What you do is you bring that exponent down in front, so the n comes down in front of the variable of x, and then you take whatever the original exponent was and you subtract 1. So for example, if I had x to the third, I bring that 3 down in front, I write the x, and I subtract 1 from the 3, so I get 2. So there is the derivative. If this is y, this is y prime. They're not equal. This is the function. This is the derivative of that function. Bring that down in front. If you have e to the x, okay, the derivative of e to the x is just e to the x. So whenever you see e to the x, the derivative is just e to the x. Just the same thing. E to the x is e to the x. If you have a constant in front of that particular function, so the constant times a function, you can bring the constant out and then take the derivative of that. So, for example, if we change this to say, let's say 2x to the third, that's our y, and we want to find y prime. We can keep that constant there, find the derivative of this, which is 3x squared, and then 2 times 3 is 6, so you get 6x squared. Now you don't have to do that every time. I'm going to do that today just to kind of break it up a little bit more, but you can take the exponent, multiply it by the constant that's out in front, and then still do your subtracting right there. Subtract 1 from the original exponent. So 6x squared. Now we also have the sum and difference. So if we're adding two functions together and we're taking the derivative of that, we can separate. We can find the derivative of the first, the derivative of the second, or terms. Okay? If we have terms, 2x squared plus 3x plus 8. We can take the derivative of 2x squared, we can take the derivative of the middle, and the derivative of the last, and just separate them. So we can take the derivative of each of those terms individually and come up with our answer. So today, everything has to look like this. We have the product and the difference rule also tomorrow, but we don't have, or the quotient rule. We don't have those yet, so anytime we have something multiplied together, it's going to be a constant, something like this. We can't have two functions multiplied together yet. Or if we have a bunch of terms, we can separate them out. Okay, so if we have some things we do today, you're going to have to do some cleaning up or get it ready to take the derivative, because the form that it's in, we don't know that yet, what to do. All right, so differentiate. Find the derivative. Yes. Mm-hmm. Mm-hmm. What's x to the 0? 1, so it'd be 1. That's correct. All right, so here we have a constant times something. Now, right now, what I would do, a lot of times when you have parentheses, you want to get rid of those parentheses. That'll make it a lot easier to find the derivative. You don't have to distribute. We can consider that 1/4 like a constant, and the t to the fourth plus 8, two terms, find the derivative of t to the fourth, derivative of 8, and then distribute that. But I'm going to distribute that. I always want to get rid of parentheses. So I am not doing anything yet. This is still g of t. We are not finding the derivative. All I'm doing is getting rid of those parentheses. So that becomes 1/4 t to the fourth plus 2. So now I want to take the derivative of two things being added together. So I take the derivative of this, and I take the derivative of that. Okay, so now I can say g prime of t equals, this was not the derivative, this was just multiplying, changing the way it looks. So think of just this term right here. Again, some of you know this rule already. If you know it, terrific. If not, I'm going to do a couple steps today just so you can see. So this is our constant, 1/4. Then we take the derivative of t to the fourth. Our power rule means we bring that 4 down, times t to the 4 minus 1, which is 3. The derivative of a constant, 0. So our derivative is t cubed. This middle step, this step I showed right here, right before it, is not necessary. If you need to write it right now so you can kind of see what you're doing, fine, so you can match it up to the rules, but that step is not necessary. 4 times 1/4, we multiply that 4 times the number out in front, 1/4 is 1, t raised to the 4 minus 1, which is 3. The derivative of a constant is 0. So there's your derivative. Before this, we would have had to plug in a plus h in for t, then do a plus h times a plus h times a plus h times a plus h, multiply all those together. We would have never given you, that's why you've only seen something squared. You haven't seen anything to the third and fourth until we have these rules. So now those exponents can be anything. It can be to the 10th. You don't have to multiply something by itself 10 times. All right, here, there's no parentheses, there's nothing to clean up, but we have to think of this right here, 4/3 pi, that is a constant. That's your c right there. So v prime of r, if we want to show this middle step again, 4/3 pi is our constant. Then we can take the derivative of r to the third, bring the 3 down, r to the 3 minus 1 squared. And now we have to multiply those things together. We can't leave it like that. 4/3 times pi times 3 is 4 pi r squared. And volume of a sphere, surface area, we take the derivative of the volume of a sphere, we get the surface area of a sphere. Later on, you're going to have to know those formulas for some problems we do, optimization. Okay. If you recognize that, terrific. If not, that's okay. All right, this one. So we have this ratio. We don't have any kind of rule for the quotient yet. We don't have any dividing rules. So we've got to make this look like an adding and subtracting problem. No ratios, okay? No numerators and denominators right now. It's always easiest if you can get it into terms anyway. When we learn the quotient rule, that's going to help, but it's always easier to get it into terms if you can. So let's think about this in just simple numbers first. If I had 1 minus 2 over 3, that's the same as saying 1 over 3 minus 2 over 3. If you have common denominators, you can combine your numerators. Okay, just thinking of it in terms of regular numbers. All of you know this right here. It's not as easy to recognize with all this crazy x and roots and squares as it is with just regular numbers and or just x's. So we need to split this into 2 because we can't do anything. It's not ready to take the derivative yet. So we can say y prime equals x squared over x minus 2 root x over x. And then we can clean each of those up individually. So our exponent rules. We've got to remember those exponent rules from Algebra 2 in pre-calc. X squared over x is just x. 2 minus 1 is 1. Minus 2. This root x is x to the 1/2. So really what we have here is 2x to the 1/2 over x to the first. Our exponent rules, top minus bottom, is 2x to the negative 1/2. Now, we don't like negative exponents, but right now we do like them because if we got rid of that negative exponent and made this 2 over x to the 1/2, now we're back to a fraction. We don't want fractions right now. Okay, no fractions. We want everything to be in the numerator. So while our answer, I'm not going to leave negative exponents in. Usually the directions say no negative exponents. If it doesn't, then you can leave negative exponents. But again, typically we'll say no negative exponents. But this isn't our answer. We haven't even done anything yet. Oh, I said y prime. Don't do that. I haven't found y prime yet. Yep, take that away. Take that away. All I've done is rewrite y. Okay? I have not done anything yet. I've just simplified that problem up. All right, so now it is ready. We have a term minus another term all together. So now we can take the derivative, y prime equals. This is 1x to the first. So 1 times 1 is 1. X to the 1 minus 1 is 0, which is just 1. X to the 0 is 1. It's not 1x. Anything to the 0 power is 1. If you need to write this, write it. If not, you can go straight to 1. All right. All right. Then we have minus our constant. Bring down your exponent, negative 1/2. X, subtract 1. So negative 1/2 minus 1. Minus 2 over 2, negative 3 over 2. Some of you will want to write this step, some of you won't. Now we can clean that up. Negative times a negative is a positive. 2 times 1/2 is 1. X to the negative 3 over 2. Obviously you have to have this 1. The 1 in front of the x won't usually be there. Now, again, if the direction said no negative exponents, okay, so let's say the direction said no negative exponents, then y prime equals 1 plus 1 over x to the 3 over 2. This would be a problem that would maybe be on the multiple choice part. And let's say that's not an answer choice. Maybe there's radicals in our answer choice. So 1 plus 1 over x power root. Maybe that's an answer choice. That's the same thing. Maybe it's all combined into 1. If it's all combined into 1, we need a common denominator. So clever one, root x to the third over root x to the third. So root x to the third plus 1 over root x to the third. All of those are the same. 2 times 1/2 became 1. So I used the constant with the power rule. So my constant was 2. So I brought my constant down, and then I used the power rule for this. So I brought the negative 1/2 down. X to the negative 1/2 minus 2 over 2. So that's where the negative 3 over 2 came from. Okay? And again, this step right here, some of you can do in your head. Maybe right now, like at the beginning, it's nice to do that to kind of see what you're doing. But eventually you'll say, okay, well that's, bring this down, multiply by the 2, and you can get straight to 1. If you can do that in your head, terrific. That is not a step that is necessary that has to be there. I'm just showing it right now since we just now learned it. So any of those answers are acceptable. And again, this would be like a multiple choice type question, something on there. And later on, this will be just a little part of a problem that's maybe 10, 15 steps. This will be within the problem. And this will be the easy part. Eventually will be the easy part. It will. Okay. Any other questions where anything came from? Okay. All right, this one is not ready to take the derivative either because it has all those square roots, and we don't know anything about square roots. There's no rules that involve square roots. So u equals t to the 2/3 plus 2t to the 3/2. Square root means the root is 2. There's no root smaller than 2. Roots are always integers right there. Okay, so now we have two different functions right here, so we find the derivative of each of those. So u prime equals, there's a 1 right there, so we bring down the 2/3. T, subtract 1, negative 1/3. 2/3 minus 3/3 is negative 1/3. Plus 2, I'm bringing the constant down. Now the power rule, 3/2t, subtract 2/2, I'm subtracting 1 to the 1/2. And now clean that up. I'm going to get rid of negative exponents because a lot of times it says no negative exponents. So this would be 2/3t to the 1/3, or the cube root of t. I'll write it that way in a second. Plus 2 times 3/2 is 3t to the 1/2. Or if you rather put it back in radical form, that could be the case. So we could say or 2/3, the power is 1, the root is 3, plus 3 root t. Either one of those would be acceptable. And on the AP test, you don't know which way it's going to be. Like if you want to write it one way or the other right now, it doesn't matter. But you have to know that those are the same. Because you don't know what the multiple choice, which one of those it's going to be. Or it's going to get a common denominator. That could even be the case also. So again, problems like this are going to be little parts of huge problems that we do later on. All right, find the equation of the tangent line to the curve at 1, 9. We've done these exact same problems, but we've been doing them using the definition of a derivative. We don't need to use the definition of a derivative. We have rules now. But we don't have any rule that has something squared. So there's a thing called the chain rule we're going to learn also. We don't know the chain rule yet, so we can't just bring this 2 down here, keep this, and go on. We have all this stuff in the middle, so we have to get rid of that. Parentheses. I like mine to be in order, so I'm going to reorder it as 2x plus 1. That's what that means. 2x plus 1 times 2x plus 1. So it's 4x squared plus 4x plus 1. 1 plus 4x squared is no different. It's the exact same. The order does not matter. Now it's easy to take the derivative of. I have these 3 different parts I'm taking the derivative of. So y prime is, I'm going to show this middle step still, 4 times the derivative of x squared, 2x, plus 4 times x to the 0, plus 0. That step I just wrote may be necessary for you, maybe not. If you knew the power rule already, someone showed you, you might not need that step. If you don't know it, maybe that step's necessary. So y prime equals 8x. X to the 0 is 1, so 4 times 1 plus 4. The directions say find the equation of the line. Equation of a line. Y minus 9 equals the slope, x minus 1. Well, we have the slope of the tangent line is 8x plus 4. The slope of any tangent line is 8x plus 4. We want the slope of the tangent line at this point. So now, we just plug in 1, y prime of 1, 8 times 1 plus 4. Well, there's your slope of the tangent line at 1. So, 12. Much easier than plugging in a plus h, doing all that work, getting a common denominator, factoring, whatever it is. Yes, this will give you the slope of all the tangent lines. So we could do it at any point we wanted. Any single point we wanted. Now, what if it just said tangent to line at x equals 1? Could we figure out the 9? If we were only given the 1 as the x? Yes. We could plug it in and figure out what the equation is. Absolutely. We plug in a 1, 2 times 1 plus 1. 2 plus 3 squared is 9. That will always be the case. So whether you're given the actual point or you have to find the y value, you just plug it into the original. So this gives you the equation for the slopes of all the tangent lines. We only wanted the one at x equals 1, so that's why we plugged in 1 to get our 12. Same exact thing we did before, it's just we use the rules now. We can use the power rule there instead of the definition of the derivative. All right, what values of x does the graph have a horizontal tangent? Horizontal tangent means the derivative is 0. The slope of a horizontal line is 0. So we need to find the derivative and set the derivative equal to 0 and see if there's any x values where that happens. All right, so f prime of x equals, bring this 3 down, 3x squared. I'm going to skip that 3 times step, so 2 times 3 is 6. X to 1 less than what it was, 2 minus 1 is 1. 1 x to the 0, 1. So there is your derivative now. We want, yes. What's the derivative of a constant? 0. The derivative always lowers that degree by 1. Okay, derivative always lowers that degree by 1. There wasn't even a variable there, so we can't use the power rule for that one. So we want to know, when does the derivative equal 0? Well, we found the derivative here, 3x squared plus 6x plus 1. We want to know when it equals 0. First step should always be to factor. Try to factor. Not possible to factor that one. So next step is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Sometimes this would be a calculator problem. If you had a calculator, plug that in, see where it crosses 0. Find your zeros on your calculator. If you don't have a calculator, then quadratic formula. If you just think it's factored, but you can't factor it, quadratic formula always works. Try to factor first, but if you just can't figure it out, use the quadratic formula. So 36 minus 12, we get 24 over 6, which can be simplified to negative 6 plus or minus, that's 4 times 6, 2 root 6 over 6. Those 6's cannot cancel, but the 2 and the 6 can cancel. Divide by 2, divide by 2, divide by 2, and negative 3 plus or minus root 6 over 3. Or if you want to break it up even more, negative 1 plus or minus root 6 over 3. I would leave it like this, but you just have to know that's the same. So if we did negative 3 over 3, root 6 over 3, you could get that answer right there. So just be sure.